All right, third video, starting on question number 8. A standard deck of cards has 4 suits: spades, hearts, clubs, and diamonds. I know you guys normally don't mess with cards. Each containing 13 cards. The players take turns, each drawing a card at random from the deck and placing the card face up on the table. When it is the 5th player's turn, there are 2 diamonds, 1 heart, and 1 club on the table. What is the probability the 5th player will draw a diamond? Okay, so there's 13 of each suit and 2 already on the table. So now my part, I've only got 11 diamonds left. Does that make sense? Okay. Now, if you look at your answers, it should be obvious what your answer is without having to go any further. But we'll go ahead and finish. So all together, if there's 4 suits and each has 13, that's 52 cards minus the 5, or excuse me, minus the 4 that are laying there. That would leave me with 48. So 11 out of 48. So my answer is G. Okay. As soon as you see that 11 on top, you can rule out F, H, and J, right? And 13 doesn't make sense because you don't have just diamonds. You have hearts and clubs and spades. Okay. So you have 3 other different cards. So if you really were paying attention, you could have answered that just by knowing there was 11 left of diamonds. All right, you rolled a standard 6-sided die, numbered from 1 to 6, 10 times, recording the numbers that you rolled each time. You recorded 4, 2, 5, 5, 5, 1, 6, 1, 2, 6. What is the probability that your next roll will be a 3? Well, it doesn't matter because the previous rolls have no impact on the current roll. Does that make sense? So there's only 1 3 out of 6 sides, so your answer is 1 6. This here is unnecessary information because it has no bearing on the future roll, okay? The die doesn't say, oh, well, I've rolled a 4 and several 5s, so let me cut my chances down. No, it's totally random, okay? All right, number 10. Rolling doubles occurs when you roll the same number on each of 2 dice. What's the probability rolling doubles with a pair of regular 6-sided dice numbered from 1 to 6? Okay, so this one's an interesting question because it's not like drawing cards where you draw 1 card and you don't replace it, but you're wanting 2 different events to occur. So when I'm doing that, I have to multiply, right? Now the chances of getting a particular number is 1 6, and the particular same number on the other one is 1 6. So if I multiply, I get 1 over 36, okay? So sometimes we talk about snake eyes or whatever, right? So you have a 1 out of 36 chance of doing that over time, okay? All right, number 11, a fair coin and a 6-sided die number from 1 to 6 are tossed at the same time. What's the probability that will land so that the side facing up on the coin is heads and the side facing up on the die is an odd number? Okay, so let's think about this. A coin, it's only 2-sided, right? So what is the probability that it'll land side facing up? That's 1/2, right? And then on the die, or on the die, that's 1 dice, okay? Dice are singulars, die. If I think about that, how many odds do I have? I have 1, 3, and 5. So that's also 1/2, right? So if I were to add those, I would say that it's a 1 probability, which would be that it would happen every time, and we know that's not going to happen. So the only thing that makes sense is to multiply 1/2 times 1/2 is 1/4, right? So my answer is C.